Okay, in this video I want to continue talking about integration by parts, but we want to see that integration by parts can be used in a repeated way. And this will often happen when one of the factors in the product is a polynomial of degree greater than 1, in which case you'll have to continually apply this integration by parts in order to finally evaluate the integral. So we start off with, again, based on Lippitt, we're going to use x squared as u, sine x dx as dv. And we'll differentiate x squared to get 2x dx, and we'll integrate sine x dx to get negative cosine x. We'll start to put it together. Integral u dv is equal to uv, which is going to be negative x squared cosine x, minus integral v du, minus the integral v, which is negative cosine x, du is 2x dx, so the negative sign is going to come out and make that positive. And then we'll have the integral of 2x cosine x dx. And here's the point where we see we still need to use integration by parts since we still have a product there. Each time you perform this integration by parts, that polynomial will lose 1 degree. So this time our u is 2x, and the dv is cosine x dx. Alright, so we're going to differentiate u to get 2 dx and integrate dv to get sine x. So once again we put it together and we still have negative x squared cosine x plus uv, which is 2x sine x minus the integral of v du, and that'll be 2 sine x dx. And at this point we should be able to finish this up. So we'll start again. We have negative x squared cosine x plus 2 sine x, 2x sine x, right? And then we want minus, and we can just integrate this directly, but the integral of sine is negative cosine. So we're going to get minus and negative, or plus 2 cosine of x plus c. So in this particular example we had to integrate 2 times. Use integration by parts twice. Okay, so here's one for you to try. Just a slight variation on the one above. X cubed cosine of x dx. Again, our u is going to be x cubed. Our dv is cosine x dx. Then we differentiate or find the differential of u. That'll be 3x squared dx. We'll integrate cosine to get sine, and we're ready to put this one together. We have uv, which is x cubed sine x. Then minus integral v du. V is sine, du is 3x squared dx. And so we're going to need to do integration by parts again. We have the integral 3x squared sine x dx. So u will be 3x squared. dv is going to be sine x dx. Find the differential of u. That'll be 6x dx. And the integral of dv would be negative cosine x. And we put it together. We have x cubed sine x minus, and I'm going to put this in parentheses, uv. That's negative 3x squared cosine x. Then minus integral of v du. And here the v is negative cosine, du is 6x dx, so the negative is going to come out and make that positive, and again all in parentheses. So I'm going to go ahead and simplify, making sure to take care of the positives and negatives there. And we're going to have to do this one more time because we still have 6x cosine x. U is equal to 6x. dv is cosine x dx. The differential of 6x is 6 dx, and the integral of cosine x is sine x. And we start to put it back together. So we still have x cubed sine x plus 3x squared cosine x. Then a minus sign, I'll put this in parentheses. uv, which is 6x sine x, minus the integral v du. And I will simplify one more time. And now all we need to do is to integrate the sine x, which is negative cosine x, and that'll do it. And so here was an example where we needed to use integration by parts 3 times. And that wraps it up.